I think everyone's here, right? We could start. Okay. Hello. Madhu, you need a technician. Huh? Do you need a technician? Yeah, I think the battery might be. Okay.
5 lines.
Hello. Yeah. Battery might be low in this.
We are organizing the battery. You continue.
Okay.
It might survive for a minute or two.
Okay. So,
No.
Maybe take
No.
that mic.
Leave that.
okay. Hello? Okay, so the question we're going to inquire into in this session is the one up here. So, given those many number of straight lines, and exactly, I think I can say this, 49,321 points of intersection per line. That means each line has the same number of points of intersection, those many. And these points of intersection are from the other lines. So it is one of the lines has to intersect with exactly these many of the other lines. What are the total number of points of intersection in this configuration? That's the question we want to inquire into. So some rules of the world. Given a point, you can have at most 2 straight lines passing through that point. So you can never do this. Okay? That's so given a point, at the most 2 straight lines. So this is okay. This is not okay. Yeah, so let's start with this. And did everyone get the rule? Okay. So how would you go about solving this problem? You could try drawing it.
Any other rule?
Huh?
That's the only rule you have.
We'll put in other rules as we go along. It's more fun as you do. So, so how a mathematician would go about solving something like this is generalize it first. So how would you generalize this statement?
X straight lines, Y points.
Okay. And Y points of intersection for that. So now can you solve this?
No, before that we just see whether there is a relation. We'll try to see whether there is a relation between those 2 numbers.
No, that is not mathematical.
They're gone now. So that's a little bit hard to do.
I don't remember what it
I can tell you.
No, it's okay. So So given x lines and y points of intersection per line, what are the total number of points of intersection? Is the question that we. So how would you go about solving something like this? Can you do it directly? So can you come up with a proof of for one way or the other how many?
X number of points.
We do one, 2 lines.
Okay. So how you would go about doing this is now try simple examples. Okay? So, yeah.
Going by the rule that we have there, for every point of intersection there needs to be 2 lines.
Yeah.
So for one point of intersection, 2 lines.
And
So
only
for
two
y
lines,
points
there
of-
can't be three.
Yeah, so for y points of intersection there could be 2 y lines.
For y points of intersection, there could be two y lines. What do you mean?
So for one point of intersection, 2 lines are required, right?
You're saying for one point of intersection, two lines are required.
Yeah.
So,
So to have y point of intersections, we need to have 2 y lines, like in the number.
On that line.
so here there are 3 points of intersection, and there are 3 lines.
No, on that line, there can be only 2 y lines meeting.
Why 2y?
But then I don't consider the third line in this
So
case.
so what you said is that there have to be, if there are y points of intersection, there have to be 2 y lines. Right?
Yeah.
So, but here there are 3 lines and 3 points of intersection.
Why is it 2y?
So, where does 2y, does that work? Or,
I generalize it as for every point of intersection there need to be double.
but clearly that's not true, right?
Plus 1. If it's 1 plus 1, then it should be y plus 1 line. Yeah. Why 2y?
So let's move to simple examples, right? So let's try something. So what are the different values of x and y we want to try out? So let's go about it systematically. 1, 0, 1, 1, 1, 2, 1, 3. Let's go to 2 now.
How is this? How are you choosing? How on this?
Huh?
2
I'm
because
just
then,
picking numbers.
Can you draw some of
Can you?
yeah, 2 lines without a
So
point
can
of-
you now can someone? So is this possible? So how many points of intersection are there over here?
0. So just a
How
line.
many points of intersection are there over here?
1. So there
Can
have
you
to be
draw
2
that?
lines.
There are 2 lines.
Huh?
There have to be 2 lines.
So 1 line they cannot
It's not possible.
point of intersection.
So then this question is not. So then there may not be a total number of points of intersection. Maybe this configuration is not even makeable in certain situations.
If there's only 1 line.
Huh?
One
If
line.
there's only.
If there's only
line,
one line,
then it's not
there has to
possible.
be either 0 or wins for
So that means there exist cases of this where it's not possible to even create the configuration. So let's restate the question. Is it possible to create this configuration? Okay. So here you said it's possible. Here you said it's not possible.
No, that's not possible because there is no intersection of lines.
Okay. So
There's no
so
we need
line
at
for
least
it
2
to
lines.
intersect.
here is it possible?
No.
No.
And here?
When there's 1 line,
Okay.
there will
So
not
what is the conjecture you can come up with? A
X is
general
not equal to 1.
You need
Huh?
more than 1 line.
X has to be greater than 1.
X has to be greater than 1.
The number of lines has to be less than the number of intersections.
Okay.
No.
Is that you accept it?
What?
Number
What
of-
did he say?
He said the number of lines, his conjecture is X has to be greater than Y.
But 1 is greater than 0.
Yeah, so 1 is possible.
1 is possible.
2 lines and 1
No, but there
intersection.
your example X is equal to Y.
Can you convince her that 1 is possible? 1, 0?
Yeah. By just drawing a line without any intersection.
So it's not intersecting with anything.
Yeah, so
Yeah,
0
so it has
intersection.
0 points of intersection.
Madhav, in your
Definition is
example,
just
x
one
is
line
equal to
there.
y. So how can x be greater than y?
Huh?
You wrote over there x is greater than y, but in this example, x is equal to y. No?
That's assumption.
What? Well, so over
On the
here-
left hand side, you wrote x is greater than y.
Ah.
But in this example, x is equal to y.
No, here x is equal, y here is equal to 2.
There's a third point of intersection, no, there?
Per line.
Per line.
Acha,
per line. Okay.
The total number of points of intersection are 3. So when you were doing that problem, that was what was important. Here, the per line has 2 points of intersection.
Okay.
Right? That's the important. Okay. So why is this possible? How is this possible? You drew this. How do you know that this thing has, so one straight line has no point of intersection?
Because there's no other line.
What is a point of intersection, or what is a straight line?
Yeah.
What? I'm asking.
You are right.
Yeah.
Can I put it this way? The
Yeah.
total number of point of intersection on a single line
Yeah.
is less than the total number of lines.
Yeah. That's what. That's what.
That is not what. For example, if there are 3 lines
Yeah.
and they are intersecting,
Huh.
on any given line, the number of intersections would be less than 3.
Yeah. So this is what y represents. Y represents this, the 2. Over
On
here.
a single line,
On a single line, per line. That's what. Yeah.
Can we start with this, like one point of intersection is being formed when 2 lines intersect?
Okay. So that's what a point of intersection is. A point of intersection is when 2 lines intersect.
And that would remain true in all aspects of the rule that
Can one line not intersect itself? Did you say that we will?
थोड़ा बड़ा लिखो माधव।
This means we have to raise the question. Father hasn't heard it. No, he was, I think, made it bigger.
Two lines, you want to use intersect? We are using intersect. Just want to use intersection.
Meet.
Or share a point?
Minimum.
Always 2 lines, not the same line.
So one of the rules we have set up is that
When 2 or more lines.
that given a point of intersection, you can't have 3 lines at that point.
Why
In
not the
this
same
case,
line?
huh?
Same line.
You're saying why can't a straight line intersect with itself?
That's spherical
Yeah.
geometry
Yeah.
or something.
So why can't a straight line intersect with itself?
We have to define it that way.
Yeah. So
Because
how would you
it's
define
a-
it?
A collection of contiguous points which
Okay.
do not meet each other.
Do not meet. So then,
Oh God. Kill them.
A straight line.
so what is a straight line?
The one that you
We have a straight line is a here.
The shortest distance between 2 points.
We have to do that.
So the shortest distance between. So how does that help? Why can straight lines not intersect? One straight line not intersect with itself.
because for intersection you decided that there has to be 2 lines, right?
Huh?
No, he wants the definition.
I'm
No.
challenging
He
that.
asked the question, why can't a straight line intersect with itself? The straight line meet with itself in some way. So he's talking about something like this. Why can't this happen?
Straight line on the same plane.
Both are the same.
So he's saying something, why can't this happen for a straight line? So that's why,
Because this
Straight
is
line.
not a straight line.
why, how is it not a straight line?
The shortest
Because there are more than 2 points.
There are more than, yeah.
Okay, shortest distance, and that given,
Only 2 points.
It does not share its own points.
it
A
doesn't,
a straight line is something
it
that
has
does
its
not.
own points.
No, it does not share.
What does that mean?
2 points are always
It does not meet itself.
Okay, it doesn't,
Meet itself.
If it meets itself, then it would not be the shortest distance between 2
Okay.
Yeah,
points.
exactly.
so actually, let's leave this here for now and move on. Let's assume we know what a straight line is. Just for now, we may come back. So now let's try this one. Can this be done?
Parallel lines.
Yes.
Parallel line.
Parallel lines, or just this. We're not saying lines have to be infinite. They can be finitely wrong. So, or
Those will meet somewhere.
no, but lines
finite
can be
lines.
finitely wrong. We're not making that stipulation that lines have to be infinite. So these two or this and this would be lines which don't.
2, 1 is possible. The next one.
So 2, 1 is possible.
2, 2 is not possible.
How is 2, 1 possible?
Because that's the rule also. It's the first rule also.
No, so how can you create 2, 1? So you just take
Equal
line.
lines and they meet at one point.
Okay, let's accept that now.
2, 2 not possible.
Why?
Because that's what you said.
Because a line cannot meet
Your
itself.
rule says in the law it has to be said that.
So you have to prove. So now, if you want to say 2, 2 is not acceptable, you have to prove this.
Yeah, that's the rule.
The number of lines has to be greater than the number of points of intersection per line. How would you go about proving it? So assume you have this. If x is equal to 1, y is lesser than 1. Right? We got to that. Now, given this, can you prove this?
I can say we have to use the proof of contradiction,
Okay.
but I'll stop there.
That's also a good step.
I'll make my contribution.
Yeah. So how would you go about doing it? So given
Let's
Within the
do that
indirect,
what is that?
the indirect method or the contradiction. So x is equal to 1 and y, we say that we assume that y is equal to 1.
no, we assuming we proved this. I want you to prove this.
Oh, that is assumed.
Let's assume for now. We proved this. I want you to prove this.
So for every two lines, there's always which are intersecting. There's always one point of intersection.
Okay. Fine.
And but it is possible to have a line without a point of intersection.
Okay.
So if you require at least two lines for a point of intersection, and also it is possible to have a line without a point of intersection.
Okay.
So then that
Adds up.
that is a beginning
Okay.
of proving that there will be more lines than points.
Let me have a little bit. So now, pick out one line from your x lines. How many lines are left?
X minus.
For a given line, how many points of intersection do you need?
1.
So meaning for a given point of intersection, how many lines do you need?
2.
So given that you have this line, how many lines can it intersect?
X minus.
So how many points of intersection can it have at most?
X minus.
So y can have only 2 values.
Can you just say that
0
again?
or 1.
Please?
Yeah. So let's pick out one line from our x line. We're just putting it down here. You have how many left?
X minus 1.
X minus 1 left. Now, if you want, now you want to have the most number of intersections you can on this line, right? And for a point of intersection, how many lines do you need?
2.
So how many points of intersection can you create given this line and these which are remaining on this line?
X minus
Maximum.
2 into 2.
X minus 1.
X minus 1. Right? So you can create x minus 1 points of intersection. At most. Okay, you can't create more than that. So the most number of points of intersection per line has to be, so y is bounded above by x minus 1.
Y cannot be
So
more
y,
than that.
meaning the maximum value I can have is x minus 1.
Yeah.
Okay? So x is greater than 1. So now we don't need to touch this, we don't need to touch 2, 3, we don't need to touch various other things. So now let's involve so maybe in pairs or something, can you guys try and work out each of these? Spend like 5 or 10 Are these possible? For each of these, are these possible or are they not? Yeah.
So we said earlier that one line can only intersect with one other at one point. That was the rule.
One line can intersect with more than one, as many.
No,
but
at one point.
So given a point, only 2 lines can
okay,
meet
but
at
on that line there can be various
Yeah, so you
ones.
can have this. That's okay. Did everyone get what you need? Is this possible? Is this not?
Intersection per line will exist. Y is points of intersection
Per line, and so equal numbers per line. So if
So there are three and 2.
yeah,
That means every line
has to have 2 points.
It is possible. 4 parallel. 4 and 1 possible. 4 and 2.
One may be outside.
Oh, space point of intersection line is Y points of intersection per line.
Every line has to be intersected.
That's what I asked.
This line has
Here's
what you say is
So what is 3 now?
This is what I got from 3 to see for every 3 lines, 2 points of intersection are there. Control and C. But 3, 1, how it is? 3, 1 is number of lines. 3, 1 is what?
on all lines.
See, if you are drawing, there is 3.
Third line, yeah.
Yes, it is not valid.
Does every line have, so does every line intersect with some other line?
Why is the number of interactions per line?
The question that you does this word, does every line intersect with another, or are there some lines just floating around also?
No, every line has to have 3 lines. All of the 4 lines have to have 1 point of intersection. All of the 4 lines have to have 1 point.
So there's no line outside that?
No. This is a very strict word. Only those men.
This has to be X by X.
So 3 minus
So 1 0 gets equal to 3. You must have one. Then you are acceptable.
Even if you have like this,
1 0 नहीं लिया है.
No, it's not possible. If you have a false line, we have to keep
Project starting with 0.
Keep taking your ground here. 3 and 0 is not.
1 0 how it is possible? This one must have 1.
6 will 3
Just one line, 0 points of intersection. Y is points of intersection.
7 lines.
All these are possible. All these are 0 possible.
Find 1 or
3 1 is not possible. 4 1 is not possible.
even find 1 is not possible.
Because the 7
Can be possible. 3 possible.
will actually 8 lines.
4 and 2 is possible.
If you draw a line through all those lines, that is the include. You will have 7 points.
This line has 1.
So it has to be X minus 1.
4 2 is this. Oh, this we already said 4.
The hash.
Another way of saying 4 and 2. This is 4 and 1.
So if you have these many lines, then the points of intersection will be this minus 1. You have 1 for 9 lines, and the remaining are all 1 line.
Why is that not? 5 lines. 1 line, then we'll have 5 lines.
Well, it's the window point is 4, 3.
No, each one must have 3. That's what.
Actually, we need the space.
Each one will have. Every should have.
5 is again possible.
So we said 4 and 1 is
Draw pentagon. Yeah, 5 is possible.
Everything with 2 is very easy.
But does every line have 5 the same number?
But if it has if it is C, if it is X,
1, 2, 3, 4. 5 points of intersection per line. Then 4 leaves. The same
You are drawing parallel lines.
but why are we doing this now? Already it is X.
No, but then x minus 1, we, like if you go by 4, 2, that's not x minus 1.
No, maximum is X minus 1.
Yeah, but now you have to say whether 4 1 is possible, 4 2 is possible. Why can you create it?
For 1 you can draw 3 lines and 2 lines, and the remaining 2 will intersect, so we'll have only 1.
Every
You
line
have
has
4
to-
lines with 1, 4, 3, 1.
Okay, so do 3 1.
Parallel one will not be possible.
Oh, it has to be 4, 3. No,
But again, that all 3 1 is not allowed.
That was the first
3 1 is possible, no? There's 3 lines and 1 point of intersection, so 1 line will not intersect.
That is not possible.
Every line has to see the question. Given X lies in exactly Y points of intersection per line. Every line has to have Y points of intersection.
Same as
Okay, so there cannot be a line which is unintersected.
Unless there's 0 points of intersection.
Wherever there is 0, you can use that. There are no points.
Okay.
No, but you cannot have you cannot have one line having one intersection and another line having 2 intersections. That is not allowed.
You are trying to say that I have 22 points and there is one more point.
No, I'm saying that C, supposing you have 3 lines.
Okay, let's get back to so can somebody tell me which ones of these are possible?
Why?
3 0 is possible.
Why is 3 0 possible?
3 1 not possible.
Everyone agrees?
X, this should be
3 2?
Possible.
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 No.
Possible.
No, one possible?
No, 4 1 is not possible.
4 1 is not possible.
Possible.
Some people are saying possible, so I'm going to leave this as.
Okay. 4 2 is possible.
4 3 possible.
3 not possible.
just saying
5 0 yes.
Possible.
I have written no. They're saying, see, that is the same.
Okay. So I'm going to. So how would you draw 3 0? I'm not going to ask you. How would you prove that 3 1 is not possible?
Because if you draw 3 lines, there will be on one line there will be 2 points of intersection. On one line there will be 2 points of intersection.
Or on one.
But then maybe you're drawing it wrong.
Or on one line there will be no point.
Remove that one line and try to intersect. It intersects in both.
That is what John is telling.
We have 3 parallel lines.
Ah.
Remove one parallel line, and then that let's take slant it anyway. So that will intersect.
Transversal.
So maybe there's another way to draw 3 1. Maybe why are you drawing it in this way? So you have to show that no matter what you do, 3 1 is not possible. You can't say that this way 3 1 is not possible, therefore because
No, he's saying it's possible.
He's saying this is possibility. 3 1.
No, he's saying 3
No,
1.
one line has
Points of
One line has
intersection.
2 points of intersection.
This line is 2 possible. So you can't say that just because it's impossible in doing it one way, because I can tell you here 3 0 is not possible, right? That's not true. You
That's not.
yeah
That we have to extend further.
yeah. So how can you prove that 3 1 is not possible? Try the trick I did with the pulling out one line. Yeah. So can someone come up with an argument? Pull out one line first.
So 2 lines to the left, they will intersect max at 1 point of intersection.
I mean, they will. You haven't put them anywhere.
No, we can pull out 1 line, 2 lines are left.
Yeah,
So maximum they will be able to intersect at 1 point.
So
So if this line also intersects them.
But why does it have to intersect? This one, why does it have to intersect? So you pulled out one line, now what would you, now what do you have to have?
We are left with two lines. And if, let's take when we are taking another line and if we are making it intersect with this line, the one more line is left.
Okay. So you're saying there's two lines left.
Yeah,
okay.
2 lines left.
You're picking one.
And then if we use that to make it intersect one.
Okay, why are you doing that?
We are trying to get to one.
Okay, so you have to do this is what he's saying. There's no other choice.
Yeah, if you have to get one intersection.
Yeah, so if you want this to have one point of intersection, does everyone understand what that is?
Yeah.
So in order, since you have to get one point of intersection, you pick it up and you have to make it intersect with this if you want every line to have one point of intersection. You have no choice in the matter. Unlike in that situation, you had a choice. You could pick it up.
Yeah.
Right? Now you have one line left. What?
However we put that line, it will intersect with.
So either the line intersects with one of these.
One of these.
And then there's one. This line has 2 points of intersection. Or it'll intersect with this, or with this, or it'll have no points of intersection.
So it will intersect with both.
So either 0 or 2.
We have to extend the line infinitely.
No. You can have finite lines. We haven't said no to that. There's no reason to. We haven't said no. Did everyone get this proof?
Yeah, that means it will be either 0 or 2. It cannot be 1.
So the last line either has could have 0, 1 or 2 points of intersection. But if it has 1 point of intersection, then one of the other lines will have 2 points of intersection.
So we have equal number of.
Yeah, you want one, not just equal. Here we want one.
Okay. Is there an elegant way of doing it, like x minus 1?
This is quite elegant.
No, but this is graphical. You know,
No. I'm saying you don't have to do it graphically. So let's take the argument without that. So you're saying pick out one line. You have 2 lines left. That the one line you picked out requires 1 point of intersection by the question, but that's what we need to create. So now it has to intersect with one of the other lines. So make it intersect with one of the other lines. You have one line left. Now either that will intersect with one of the other lines and create a line with 2 points of intersection, or it has 0 points of intersection.
If we can put it in terms of the general variables, we have n lines.
No, here we are doing 3-1. We are doing a very specific case.
No, here, but if I were to generalize, is it okay?
But you may not be able to. What is your general claim first?
No, for this, we cannot.
Meaning, if you tell me what the conjecture is with you, because here this is very specific, it's 3-1. So what would be your general statement which you want to prove?
No, I'm just trying to come up with a generalization for the number of intersections possible.
But then will it
Okay.
apply
Let me try. Maybe I'm
try,
wrong.
try.
Yeah, okay.
I'll just try. Let's say we have n lines. That's what we are having. N lines where n is equal to 3.
Keep it as x for now.
Keep it an x.
N or x lines. And then we are picking out one line out of it. So we have rest n minus 1 lines.
Let him use that n. Use n. You're more comfortable with that.
Yeah, sorry.
Use x.
Okay, x minus 1 lines we have.
Yeah.
Now, how many intersections can x minus 1 lines have with the one line that we have picked out? Which is x minus 1 intersections.
At the most.
At the most. Oh, it's at the most.
But then that
not exactly.
But one thing was that is not satisfying the thing of equal number of intersections.
Yeah, that's right.
What do you mean?
See, when you use that x minus 1, that was just to prove that y is greater than x is greater than y.
Yeah.
It is not following over here because in this one.
No, what we proved there is given a line, given x number of lines, one line can have most x minus 1 points of intersection. So it doesn't matter what those points of intersection
that I got, but I'm saying that the additional requirement of your original statement is that there has to be equal number of intersections.
Which original? This one?
No. Where that given x is a straight line, and is it possible to create that configuration?
Yeah.
So that is not satisfied in the x minus 1 diagram which you drew.
Yeah.
Because that one line is having all the.
We are not worried about any line apart from one. In that situation, we are just worried about what's the most number of points of intersection you could possibly have. We don't know whether it's possible to do it. We don't know whether it's possible to create a configuration of x, x minus 1. We haven't proved that. That's not proved as yet.
Yeah.
So
I'm saying that additionally from this, now we have to have a configuration where every line has an equal number of points.
If we want to prove this,
yeah.
But we haven't got there yet. That's much more complicated. Okay, so can someone spot a pattern here? So you're saying 3 zeros is possible? Huh? All zeros are possible. So x 0 is possible.
No, y. X 0.
Whatever.
X
For all.
X2 is possible.
X1 is not possible.
Huh? No, first let's prove this.
X2 is possible.
How would you do this?
Non-intersecting lines.
Just and non-intersecting. X non-intersecting. Okay. That you can draw those many non-intersecting lines is a separate question, which we'll leave for now, but something you can think
Finite lines.
Yeah, but how do you know you can draw X non-intersecting finite lines? How do you know you can draw 10,000 non-intersecting finite lines?
Parallel lines.
How do you know you can draw that many parallel lines? So, meaning we leave this for now, but think over it. Go back to the what Jayashree gave in the morning, and you can think about that later. So you're saying, so are there any other patterns you can see here?
So for even numbers, like for example 4, 0, 1, 2, 3, all are possible. For odd numbers, only x
one
is
is
possible.
not
One is possible.
Okay, so for 1, let's pick for 1.
Not possible.
Who's saying it's possible? It's much easier to prove it's possible, so
Not possible. 4-1 is not possible for us. 4-3 is also not possible.
but if you can show it, then
you clear it.
Ah.
4 lines and 1 point of intersection per line.
Wow. No, one we did. I mean, one line has one intersection.
So perhaps what is the trajectory?
For even numbers, for example for 4, 0 to 4, all number of point of intersection is possible. For odd numbers, only x minus 1. For example 5, 0 and x minus 1 is possible.
Okay, so you're saying that the prediction from that could be as 5, 5, 2 is not possible.
Yeah.
Okay, can someone come up with the proof that 5, 2 is possible? Can you prove that?
If you draw a pentagon,
How would you draw 5, 2? So just spend like a minute or two trying to draw 5, 2.
Yeah, 5, 2 is possible.
that's what I said. If you draw a pentagon, is possible.
Yeah.
5 lines, 2 points
Right.
of intersection.
Yeah.
This one is correct.
I can't see that.
No.
Oh, yeah. How would you do it?
Pentagon,
Yes, 3. This part is 3.
Oh, no.
Draw. This part is 3. 1, 2, 3.
There's 2.
Yes, 3 lines.
Pentacle is 0.
This is meeting, but it's meeting again. So meeting is the same as intersecting, right?
Yeah. Whatever, if you want. Okay, so 5, 2 is possible, so that is a counter example to Pras's conjecture. So can you see other patterns, similar patterns, like the 3, 0 case?
All 2s are possible.
All 2s are possible.
end to end they need.
No, here see this is 2. Yeah, correct. This is 2. No, you don't need to do it like this.
Okay. How will you prove that?
way I mentioned it because it's all a polygon.
Okay.
But I don't know how to prove it.
No, so you're saying, how would you go about drawing, if you're given a random x, and you're given that you need to create x2?
I'll get an enclosed shape.
Huh?
I'll get an enclosed shape.
But more specific, how would you go about drawing? Enclosed shape, this is an enclosed, I don't know what.
No, straight line. No?
So but an enclosed shape is what? So this is an enclosed shape. Oh, like something. So what do you mean by enclosed shape? Go further.
Without any line inside.
That's a little more complicated. You were saying something closer earlier. So polygon?
Oh, I said polygon, yeah.
So how would you? So what type of polygon would you draw for x2? How do you determine the polygon?
Polygon that has only two intersections.
So an x-sided polygon.
X-sided.
So we can do this for infinite numbers.
Does everybody see what's happening? An x-sided polygon. So what he's saying is, so for 3, 2, you draw a triangle. For 4, 2, you draw a square. For 5, 2, you draw a pentagon. For 6, you draw a hexagon. And so on. Okay. So why would a n-sided polygon result in x2 every time?
Because of the vertex
that many number of
points of
vertex.
intersection.
So what is a polygon?
Is it more than 3 sides?
A straight line intersects only at 2 points.
And all lines intersect. All lines intersect, and each line has only 2 intersections.
Only 2 points. That one doesn't have 2 points.
All lines intersect,
And each line has to have only two intersections.
Only 2 points.
Okay, so but you see, you're kind of going from the what you were trying to prove to. So meaning that's acceptable actually, because you're defining a polygon in a certain way, and then basically by definition this follows. But okay, let's move on. Let's see what happens. So any other patterns you see? So now we know that 6-2 is possible, 7-2 is possible.
5-3.
I see a clear pattern, Mark. That anybody comes up with a pattern, you have a counter with that.
Okay, conjecture pattern. Can you come up with a proof to that?
Has to be mathematical proof, right?
Yeah, mathematical proof from axioms and definition.
I don't know about 5-3. Did you do 5-3?
No, 5-3 I don't think you guys.
We can't do it. The 2 x is 2. 0.
Looks like both x and y cannot be odd numbers.
For all even you will have that.
That is a shoot in the dump. Now I have to do it.
Yeah.
So you'll have two
That
such
would be
figures when it comes.
extremely hard to do. So,
But is it right?
I don't know. If it's provable, I would suggest it. I would expect it's quite a hard proof. But if we try it out. But I'm not going to follow that up right now, because that's going to be if you need to prove that or find a counterexample, it's going to be hard. So let's.
I'm just
But,
looking at it.
but keep it. Keep this in mind. Like, try and figure it out. So what we've been doing so far? So far we've been keeping one of the variables stationary and varying the other. Right? So we've done it for 0, we've done it for 2. What about for the rest?
Yeah, all
this is one technique, you keep one variable fixed and you move the other.
This is all one. So one is possible because this you can do for any name.
If you assume your theorem is true, what consequences does it have for x1?
For x?
1.
X plus 1.
X comma 1.
X comma 1.
So y is equal to 1. So, what consequences does, if you think this is true, if you assume this is true for now, what is the consequence it has for x?
So x cannot be an odd number.
X is even.
But can it be even?
Yeah.
Will it work always for every even number?
Always.
We've tried it for
Yeah? Yes. So you're saying
We have a feeling that it will happen.
If y is equal to 1, x is equal even.
so y is equal to 1, so this is if and only if. So that means it works in both directions. So y is equal to 1 if x is even, and if x is even, y is equal to 1. That's what that if and only if means. So how would you...
But if x is even, y can also equal to 2, no?
Huh? No, we are only making a claim for when y is equal to 1.
Yeah.
So can you prove that?
What?
Y is equal to 1 if and only if x is even.
So, for example, if you take that example of 4 lines, if there were 5 lines, then 1 line would be left. In that way.
But maybe you just do it wrong once again. You're assuming the starting and then adding one more line.
In any case, for example, if it is 5 or n number of lines, if you are taking 2 lines and intersecting, that is out. So finally we will be left with 3 lines. Okay, in those 3 we take 2 lines, then the 1 line will be left.
That was actually wrongly stated. How would you state this?
If there's one point of if there y number of point of intersections, then the
intersection, then
x is equal to
Yeah. So if
2y.
Actually, it's not an if only. If y is 1, x is even. Is the claim here.
Yeah, x become double y.
no, not double.
So how would you? So yeah, Karnamurthy, go ahead.
So if y is 1, x has to be even. If
So prove that.
so it's the same. If you are taking 2 lines, for one intersection we need 2 lines. Okay. If we have even number, we take half the lines and that half line intersects the other half. Or we are reducing it from take one line and another line intersects. That goes out of the equation. And then we try make at the end.
Okay. So you're saying you pick one line out.
Yeah.
Now you have to make it intersect with one other line. You're left with how many lines?
X minus 2.
X minus 2.
And then you do it till the end. Then you come to 2 lines.
2 lines.
The end.
2 lines actually.
Yeah. Like
And
yeah.
done.
Then so what? So all the lines have one intersection.
Okay. Now how would you do it the other direction?
But if it's odd, then 1 line will be left.
One line will always be left.
One line will always be left.
No, so why do you have to do it in that way? Okay, so we want to start from, how would you do it? Give me the argument.
For the odd number of lines?
For odd, that's not possible.
You know, if you x minus 1 has to be even, and if y is equal to 1, you will have that 1 left in the end.
Okay.
Therefore,
No, but maybe you're drawing it in a different way. Maybe there's another way to draw it where that doesn't happen.
Okay.
So,
No, for
in any other way,
so we
So
start
say the
with
total
one
number
line.
of intersections is n.
Hmm.
Total number.
It's y.
No. Y is one intersection per line. I'm saying total number of intersections is n. Two lines are required for each intersection because there is one intersection. So 2x, 2 lines, 2x is equal.
Number of lines you have taken.
Yeah, so the number of lines is double the number of intersections.
okay. Is it?
Yeah, see, if you have, even over here you had one intersection in 4 lines, but it was, the total number of intersections are 2.
So here, the number of lines was equal to the number of points of intersection.
Yeah. 2.
but we are trying one intersection.
No, we are talking about one intersection.
Ah.
If there is one intersection
Ah.
per set of lines,
Ah.
then the total number of intersections is n.
Yeah. Why does there have to be n?
He is talking about the example that you took for 4 to.
See, supposing now instead of 4 we have 6.
Ah.
That means we have 1, but then total number of intersections is 3.
Okay.
So I'm saying total number of intersections.
But how do you know that that pattern continues?
So I'm saying that let the number be n.
Ah.
For each intersection n, there have to be 2 lines.
Okay.
So number of lines is 2n.
Okay. Ah.
Yeah.
Okay.
So number of lines, any number multiplied by 2 is even number.
Okay.
So it has to be an even number.
So can you just
Now rest you can.
y point to intersection? Each point
Requires 2 lines.
why can't each point have more than 2 lines or 0 lines? Or
Because the point is an intersection of 2 lines. We just established that.
okay. So given y points of intersection and given that each point requires 2 lines.
Yeah. So the number of lines will be double the number of points.
Okay. So each point requires 2 lines, but how do we not know that one of those other lines that it's not happening something like this?
No, the
Because
criteria
then it
is
is not
y
one.
equal to
We are considering that y is
No,
equal
but
to
how
1.
do you know something like this is not happening there? When you're saying that each point requires 2 lines.
No, for y is
Yeah.
equal to
Yeah.
1,
Ah.
if y has to be 1,
Yeah.
then
So why does each point require 2 lines? No, that's fine. But each point requires 2 lines. But why can't these lines? So why can't the 2 lines required for one of these points share a line in common with the 2 lines required for another?
Because
then why is not
point of
one?
intersection will
That's
be
the points of intersection.
Yeah.
Yeah. So that argument needs to be made. It's not obvious. Okay. Therefore, and from that it follows that the number of lines has to be even, and it can't be odd. So I actually want to demonstrate another proof for this. Okay. Given a line, given odd number of lines, so let's call it, anything of the form 2k plus 1 will be odd. Okay. And all numbers can be expressed, all odd numbers can be expressed as 2k plus 1. Okay. So pick out a line from here. Now it has to intersect with one of the other lines, right? If we want every line to have one point of intersection, make it intersect. Okay. Now, how many do you have left?
2k minus 1.
Now you can't. None of these lines can interfere with this because this is a complete configuration, right? None of these can intersect with this at any point, no matter what you do. So now, if you can prove that, so now what you need to create is 2k minus 1, 1. Right? Does this make sense?
Yes.
So because you used 2 lines to create this, and now you can't touch this. Because if any line intersects with this, now it'll ruin everything. It'll create your. So now you have to prove 2k minus 1. So now what this is doing is that you keep going so now to prove 2k minus 1 you do the same. You pick 2 and now you have to do 2k minus 3. Does that make sense?
Yeah.
And then you have to do 2k minus 5 and so on. At some point you'll hit 3-1. You already proved 3-1. It's not possible.
Yeah.
Yeah? So if you keep going backwards, subtracting 2 from odd numbers, you will reach 3 at some point. So at that point, you have your proof. So this is called proof by induction. I think Jayashree kind of touched on it when she was doing that region stuff.
Did we say mathematical induction?
Mathematical induction, not induction. Okay? So the idea is that you have this base case, so which for us was 3-1. And from that base, then you prove that if it's true for some n, then it has to be true for some n plus 1. Okay? And then since it's true, and then it goes backwards from there. So since it's true for, so your base case then it will be true for the next one, and it'll be true for the next one, and it'll be true for the next one, and it'll be true for the next one. Does that make sense? So it's like have any of you played domino? So you push down one domino and then all fall down. So you prove for the first one and then push and all come into, all fall down. So all get. So that's, I think it'll require more practice and proof by induction to get a clearer idea. But yeah, so you've proved 3-2 is possible and 4-2 is not possible. Sorry, 4-2 is possible. Sorry, 1. 4-1 is possible. 5-1 is not possible. You prove 6-1 is possible. 7-1 is not possible. And so on. I think we can probably wrap up. So notice that at each of these steps, almost each of these steps, you've done an infinite amount of work. Even with just this first theorem, you got rid of like a whole load of possibilities, right? You got rid of every 7,854,000 whatever you got rid of that. And then at each stage with these, you tried these specific things, came up with general patterns, and proved those. So you kind of done quite a bit. So now you know that 10,854,002 is always possible. Because n 10,854. Because for any x, x2 is possible. And so similarly you go on in this manner, and then your goal is to complete everything. So there's still an infinite amount of work left, even though you've done an infinite amount of work. Okay?
So that's
So this is not possible.
So then, if you have to change that x and y into numbers,
What do you mean?
like if I say x is 2,34,436 straight lines, and exactly whatever number.
You should be able to give me an answer by the end of your.
That infinite amount of work.
Yeah, but you have to do the infinite amount of work in a finite amount of time. And then give me the result. No matter what pair of numbers I give you, you need to give me the result. That's the goal of this exercise. Okay. And then go back to the original question, which was count the number of points of intersection.
Situations like this can be, say, when you have big numbers, you just have to scale it down to small numbers, try and develop patterns, use induction to.
So you
mathematical induction.
No, regular induction, meaning you were using scientific induction to come up with the conjectures, right? You would what you would do in science. So that's how usually conjectures come up.
So you use regular inductive reasoning to develop theorems, and after that you develop theorems, you use mathematical induction.
No, you use other methods, regular deduction. Like this didn't use mathematical induction. Mathematical induction was only this one particular proof, which that method of proof with that's a particular method of proof. There's proof by contradiction, which is a different method of proof.
So you mean to say by different methods?
Scaling it up, you necessarily need to use mathematical induction.
No. We proved n2 without using x2 without using mathematical.
No, scaling it up in terms of for large numbers.
Yeah, so x2. So now if the 10,854,002 is proved. You don't necessarily have to use induction.
Oh, okay.
You
But
prove it.
in your original thing, you give an odd number, so that's not possible.
In the original I think I gave odd number.
Yeah.
Yeah, but that's not true. So I'm not willing to accept it's not possible. You need to prove that to me.
So that is still remaining.
No, the whole thing is still remaining.
No, just to get myself clarified, we are proving small sets. We are coming up with small generalization or independent isolated generalizations. And then after we make up these isolated generalizations, we are trying to see if we are able.
You're trying to get patterns within the generalizations then.
Yeah, and then we'll see if we can apply that to the large number case.
But you wanted that particular large number case is not important at all.
Maybe
you should be able to do it for any pair of numbers I give you. You should be able to give me.
No, I'm not worried about that number you gave.
Yeah.
I'm just telling about the process.
Yeah. Okay.
But it's interesting to note that we ruled out certain possibilities using deductive reasoning.
Yeah, that's right. I'm not
ruled out other possibilities.
So by any method you can come up with these isolated generalizations.
You both are on.
So this is usual method in mathematics, generalized to go from the specific case of 4 million whatever to a general case and then try simple examples to see if you can find patterns. Maybe there won't be patterns, there's a possibility. So, but in this case luckily we found one. And maybe there won't be a pattern which will get you to the answer for
Because you demonstrated both deductive reasoning and mathematical induction.
The mathematical induction is a type of deductive.
This was good. Excellent.
Because given premises, the conclusions necessarily follow.
Okay. But is there some example that you can share with us of using proof by contradiction?
Have any number of points?
In this case,
may not be now.
Yeah.
And are there any other methods in these kind of issues?
So one is a direct proof like we did there. That's neither mathematical induction nor by contradiction. We constructed a case.
So Madhav, like.
So there's proof, yes, yeah.
For this case, 2k minus 1 and 1 are possible. So 2k minus 3 is, if you consider k as 3, 6 minus 3, 3, 1, which is not possible.
Yeah.
So it is proof by contradiction?
Over here?
Yeah.
How is it proof by contradiction? Sorry, say that again.
No, you said 2k minus 1 and 1 is possible. So by that pattern,
it's not possible. Therefore, that is not possible. So that is not possible. So this was like neither by contradiction nor the direct, nor mathematical induction, right? We constructed a set of intersections. So we said we pulled one out, one line out, and we got it to intersect with all the remaining lines. And clearly, you can't do more than that by definition from the earlier. So that's neither but it's called direct proof when you're actually constructing it. So meaning it's just everything else is lumped into one category, which is not this. So actually, have you seen Euclid's prime number proof? By any chance? Okay. So I can show that to you it's a proof by contradiction. So you assume that there are finite prime numbers.
I think you have stated the conjecture. I think that may be.
Oh, the conjecture is there are infinite number of prime numbers. Okay. So assume there are finite prime numbers.
Infinite or finite?
Finite.
Oh, okay.
Okay. So now you have all these finite prime numbers. So we can multiply them together. We can multiply a finite number of things together, right? So multiply them all together. So you get some big number. Okay. Now add one.
You get a bigger one.
You get a slightly bigger one. But is it divisible by any of those? Is this number divisible by any of those which are factors of this?
No, I didn't get that.
So this P, assume there are finite, infinite number of prime numbers. They are P1, P2, P3, P4. So these are your finite, assume it ends at some PS.
Maybe easier
Okay.
if you write it as 2, 3, 5 with 1 P.
Okay.
Yeah.
So 2, 3, 5, 7, 11.